Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. We're taking another look at our CMOS logic series, the 4000 series. This time we are looking at chip CD4025. It is a triple input, so it's three input NOR gates. Check my notes there. NOR gates, and we all know a NOR gate looks like this, the little bubble, and we have 1, 2, 3, so it'll be like A, B, C, and this would be, we'll say J, and J is equal to A or B or C in the inverted version of that. So if we look at a truth table over here, we have A, B, C, and J. Then we have 0, 0, 0, 1, 0. Then we have binary 2, binary 3, binary 4, binary 5, 6, 4, and 7. So now if we have all zeros on the inputs and it's going to be inverted, we are going to have a 1. If we have at least one 1, we're going to have a 0. So the rest of these are all going to be zeros because we have at least one 0 because it's an OR gate. So that's basically how that works. So if all the signals are low, we'll get a high. If any of the signals are high, we will get a low. So let's take a look at the data sheet here. So here is the data sheet. We have the 25, the buffered triple 3 input NOR gate. We also have a NAND gate we'll look at. This is it right here. I don't believe this has a truth table on it, just so we can confirm it here. No, just what the package looks like. So, and here's what the actual chip looks like. You've got some PMOS, PMOS transistors, and then you have some NMOS transistors. So that's basically how that works. And then we'll come back up here and we'll look at the pinout here. So our pinout is our voltage plus is on pin 14, our ground is on pin 7, and then it looks like we have pin 1, 2, and 8 connect to pin 9. And then we have 11, 12, and 13 are the inputs, and the output is 10. And then we have 3, 4, 5, and the output is 6. So let's take a look at the chip here. Get this out of the way. Let's go to the overhead shot. Okay, so we have here's our chip right here. Let's zoom in a little bit more. This is going to be our little testing display here. There's our chip. I don't know if you can see the number on there. There it is, CD4025. So we're going to plug that in to our board. And we're going to connect positive and ground. So this is our positive there. We're just going to use 5 volts on this. It can take more than 5 volts, but everything I do runs around 5 volts. Occasionally 3.3. So we got positive and ground, and now I want to connect these inputs to the ones on the top side. So I'm going to use some jumpers here. Yellow, green, and red. So the green wire is going to go to pin 11. The green wire here is going to go to pin 11. So 9, 10, 8, 9, 10, 11. The yellow wire's broken, so we have a yellow wire. So the yellow light is going to go to the pin next to it, and the red wire, red LED, is going to go to pin 13, and then we'll take pin 10, our output. We'll just use an orange. I don't know what that beeping was. That's weird. Oh, that's my meter. So take pin 10 and we'll plug that into our blue LED over here, and I moved that all out of view. So we have this hooked up. In theory, I haven't tested this, but we're going to test it. In theory, this should work. The light should come on. For some reason, the light didn't come on. Okay, so I want to read. I'm just going to try a different wire real quick because I had some issues with some of these. That is odd. So I want to read the signal off of pin 10. I read the voltage. So we're going to read the voltage off of pin 10. DC voltage. So and I have 0 volts on pin 10. That's strange. Pin 10 should be an inverted output. Let's see what I have on pin 9, because pin 9 should be an inverted output too. Pin 9 in relationship to ground. So I'm getting a millivolt reading on pin 10 should be high at the moment, not 50 millivolts. So I have my power to power. Let me just crank the voltage up a little bit here. I, for the life of me, don't know what is going on. Pin 10. Relationship to its ground should be 5 volts. What is this relationship to itself? So now you're getting 5 volts across my rails. Yeah, for some reason I'm not even getting voltage on the board. Getting 5 volts there. Why am I not getting 5 volts to the chip? I'm not getting 5 volts on this rail at all. Yeah, that's strange. I am going to do this. I'm going to turn my power supply off. Pull these banana jacks. I'm going to hook up a different way of doing this. Let's see if that makes a difference. This is all about electronics, is troubleshooting. So take this. There, I'm going to plug my 5 volts here and my ground there. Turn on my power supply. Now I should have 5 volts on the I should have 5 volts on the rail. I still don't have 5 volts on the rail. I have 5 volts at the chip. Okay, I now have 5 volts at the chip. My LEDs aren't lighting up. Negative. Okay, this is going to seem really stupid, but I didn't jump my strips over here. Now, I should have 5 volts there. No, I still don't have 5 volts. This is weird because the LEDs light up, so I'm getting grounding through there, but something is preventing me from getting voltage to the chip. I have voltage on the chip. What do I have on pin 10? Pin 10 to the ground of the chip is nothing. Press a button, nothing. Okay, so I have a logical high on all 3 lights. Nothing happens either. Well, I'm going to pause it and I'm going to figure this out, guys. Okay, that was my mistake. I want to know how many of you yelled at me that I had the inputs to the NOR gate hooked up wrong. I had them set to a high. So I had them coming off the power rail into the inputs instead of off the ground rail. So they're set to a 0 right now. So without the buttons pressed, they're pressed to a 0, and all I was doing when I was pushing the buttons was lighting up the LEDs. So now, all 0 inputs and the blue light is lit, but if I hit any of the inputs, the light goes off. I press all 3, the light goes off. So no matter what, so no matter which one, either or, the light will go off. So it's a 0, it's a 1, and then all zeros no matter what's pushed. This is not a very useful gate. There are other ways to draw the logic to make it more useful. So you can do two input OR gates and tie them into the other. I'll show you that on here. It makes it a little bit more useful. So let me clear this. So let me show you. You can draw an OR gate like this, or a NOR gate up. I'm sorry. Then you draw another one down here, like this. Tie this one into this one, and then there's your inputs. So then you have A, B, C. Then you have your J output. So that's another way of doing it. Because with the 2 input OR gates, you get 4 per chip. You only get 3 per chip, and they don't come up very often. So I find just using the 2 input OR gates. If I have to do 3 ORs operations, I've never come across doing 3 OR operations, but I suppose it can happen. But that's going to do it for this video, guys. Thank you for sitting through the troubleshooting spot. I'm sorry I plugged them wires in wrong. That was weird. I just wasn't paying attention, I guess. But you can visit me on these social media links, and you can help support the channel on Patreon. Maybe get me an education in plugging in the wires correctly. But thank you guys so much, and have a fantastic day.